Everyone, welcome to Manufacturing Hub. Happy Wednesday afternoon if you guys are watching live. Happy almost certainly sometime that's not Wednesday afternoon if you guys are listening after in podcast and or video format. Super excited to get into July. This month, our theme, we're talking all about data collection for manufacturing intelligence. And if you guys are watching this episode first, which I hope you're watching this episode first, we've got Brian on. We're going to talk about some of that foundations of manufacturing data. We're going to get into historian. We're going to get into MTP. We're going to go get into Vlad and I putting everything together at the end of this month. So if you guys are new to Manufacturing Hub and you're interested in manufacturing intelligence or data collection or any of those topics, you guys are in for a treat. It will be a super fun conversation today, a super fun conversation this month. So if you guys are new here, again, welcome. If you've been here before, welcome back. If you're new here, every Wednesday, Vlad and I come on. This week we've got Brian. We're going to go have a fun conversation over the course of the next hour or so. While we're doing that, if you guys have questions or comments, agree or disagree, please feel free to go ahead and drop them in the chat, either for Brian, for Vlad, or myself. Happy to go ahead and have conversations around this. Happy to go ahead and drop links, show notes, etc. as we get through this. Having said that, and without further ado, everyone officially welcome to Manufacturing Hub. This is episode 217. I want to welcome Brian to the show. Brian, welcome to the show. Thanks so much for being here.
Thank you for having me. Great to be here.
Absolutely, Brian. I think it's going to be a really good conversation. It's always a pleasure to speak with you for not only technical reasons, but I think a lot of the opinions around, North American manufacturing as well. Before we dive into that, though, could you give us a bit of an introduction of who you are, what you do, what your career path has been, and ultimately what you're doing today?
Yeah, so I'm Brian Bribe. I'm founder and owner of Mock Controls. We're a systems integrator based in Toledo, Ohio, and we help manufacturers get them up to speed with their operations. We provide data infrastructure, advanced education on what's happening in the industry, and control systems for you to connect to your machines and get that data up and out.
Let me ask you, I guess, a more foundational question. What got you started or excited about manufacturing in general?
So, circa back to January 2019, I initially just joined in through a co-op. And when I was initially thinking about this industry, I wasn't thinking about what are the cool things that it's doing. What I was looking at first was what job titles here. Like back in 19, I'm looking at, okay, what job titles are actually paying a high wage? What are they doing? Why is it so high? And one of them was being a controls engineer. So, when you looked on LinkedIn and you were comparing a mechanical engineer with a controls engineer, you could see a very big difference onto it. And the job descriptions were, you got to understand PLCs, you got to understand HMIs, you got to understand VFDs, you got to understand all these different acronyms. And for me at the time, it's like, okay, this is all new. I don't know anybody that is talking about any of this sort of stuff, but the demand is there. So I did my first co-op with it, and I stuck with that company for about a year and a half, and I just wore all the various different hats. It was a small systems integrator, and I got exposed to be able to do so much with them that I got the experience of not only programming the machines, but wiring the machines, installing the machines, doing the debugging, getting to quoting them, doing the full engineering, the write-offs. So I had just about all of the experience you would need to run a systems integrator just through this kind of co-op. So that's really where a lot of this kind of started and where the obsession kind of began. And the more that you get involved with this industry, you tend to find out how critical it is, not just to your day-to-day life, but to society as a whole. We don't get anything done until we manufacture it. And it's more important than ever to have manufacturing be at the forefront. And this is where where we've been trying to figure out what are the next things that manufacturers need. what do we need to accelerate our growth and be a more prosperous nation in just society in general. So that's what's pushed me towards this data side of stuff and why it's been such a big topic that we've been covering and what we've been growing towards.
Let me, I guess, take another step back because I know that data is obviously a big discussion topic, right? But ultimately, you've mentioned that you had to start off with understanding PLCs, understanding the general, I would say, process, understanding how things work, understanding the various interactions between the disciplines on the plant floor. So, are you able maybe to paint us a bit of a picture of what these processes sometimes look like? Because I don't want to assume that everyone in at least in the listenership understands the kinds of systems that maybe you're dealing with, right? So is it advanced controls? Is it all automated? Were you more subject maybe to older systems? Like what kind of a stack did you have to work with before we get into the data extraction, but more on the automation side?
So you're talking about what's the OT perspective that not just my experience, but the vast majority of others' experience has been in automation, right?
I would say like your experience, but mainly imagine if you take yourself like outside explaining to someone who doesn't fully understand, the OT side. They understand maybe how things are manufactured in a general sense, but what can they expect to see from the automation standpoint, walking into some of your environments?
Gotcha. I'll do my best on
Yeah.
answer.
Yeah.
So a lot of manufacturers, I would say they specialize really well in making their products. They're very good at making their products and making sure that they deliver on those products. What they're not the best at is building those machines that make their products, which if you've gone into this industry, into automation, you'll know about the vast amount of complexity that it kind of has with it. If you want to say you even have a basic drill press and you want to have it move one part from one spot to the next and just put a simple drill hole through it, the automation to it can get very complex or it can be very simple with it. But how it gets integrated with the rest of the business is always an interesting story. Most of the time, it never does. Most of the time, these systems and these machines never actually get integrated. What ends up happening most of the time is you get, as a systems integrator, you go into a manufacturer and you ask them, what problems could we solve for you? What bottlenecks, what production cell is limiting you for your throughput? We'll just have that be an example. And what ends up happening is you have a scope of work that gets defined right from the beginning on what is it that you're supposed to work on and what the expected outcome of that is. And that's where your quotes and your invoices and your purchase orders and all that stuff is based off of, is your scope of work. Now, when you're starting off this conversation, and the way that it generally goes is the manufacturer has the problem that they are looking to solve. Systems integrator puts in a quote for how much it's going to cost to automate that. And what doesn't get defined in the scope gets left out. So there are tons of different applications. There's tons of different use cases that a new production machine could provide for the business if it's part of the scope of work. But for the most part, a lot of it gets pushed out to the side for just solving the one use case problem. And so what ends up happening is that these machines get built, they get installed, they get ran off, and everything's all hunky-dory. Now the business unit wants to get information for it, or they want to involve it more with the business. And this becomes a very interesting relationship between not only the systems integrator, the end user, the manufacturer themselves, but whatever third party that they're deciding to use to integrate that machine with. So, you end up in this very interesting triad of relationships on how you're supposed to integrate an existing machine into the business, when a lot of those conversations could have been had at the very beginning of the scope of the work. where how is the business allowed to connect to the machine? Like what is IT's requirements on being able to connect, and then on the data side of things, what specific data points do they need to get up and out, and then what format do they need it for? And a lot of that information gets pushed out to the side or is not exactly a direct concern. And my suspicion with it is, one, it's priced out too far. Two, the systems integrators that we have, especially in the US, aren't set up, don't exactly have the skill set for integrating with higher level systems like enterprises, like ERPs and stuff like that. So we have a disconnect between the systems integrators and manufacturers on the OT side, who are developing the equipment, and how they can build it to where it can meet the demands of the rest of the business. And I think that's kind of where some of that disconnect is starting to happen. So that's a bit of the story on what it kind of looks like for a manufacturer to buy equipment, and some of the issues that we're starting to run into as in regards to getting it connected to the rest of the business.
I really like the way you break it down, right? And because I've in part told you a bit off stream, I've been having conversations with people who are looking into manufacturing, and I think they don't always understand these, triangles or interactions, or how it actually works, and in what context it makes sense and what context it does. And at the end of the day, it's important to recognize that it's not just a technological challenge, right? There's other variables in play, and you've mentioned a couple of them, and I completely agree, right? Some manufacturers will thrive just because of the right partner or relationship or whomever that can, again, use a platform that out of the box does not simply connect, absorb everything, and just give them the right information, right? Someone needs to actually do the legwork. And
Yeah.
so I think it's very different from other industries where I guess that is the norm, right? In software, you can just, well, I deploy a tool that connects to all of your clusters or, Docker containers. It automatically pulls all of their information, and here's a nice dashboard in whatever tool, right? So it's like these challenges I feel are not very understood unless you've spent enough time on the floor. So
Yeah, and it goes even deeper than that, where like with IT, they tend to actually have a lot of everything is very homogeneous in IT. Like they all have the same workstations, they all have the same servers, and even the workloads generally are the same. For IT, they're basing, not basing. Their premise is to maintain the system and maintain the standard that the business operates. And when it comes to the things that they have to connect at the starting point, everything is very homogeneous. It's just about the same. And then when you compare that to manufacturing, everything is heterogeneous. There is no two devices that are the same. You never get the same protocols, and you never get the same payloads. So it becomes a very difficult story of how do you connect a device that speaks a completely different language from everything else in your business, and have that still be part of it, and you can automate it. And this isn't just one connection. We're talking about thousands of devices, of applications and processes that all need to be able to communicate with one another and exchange data. But how do we do that when everything is already talking in a different protocol? None of the information is really the same from one machine to the next machine. And even with that, it's still this dynamic aspect to it too, where manufacturing reacts to the realities of the world for the business's sake to make it happen. And in that, you end up in these dynamic situations where you have a process, you have a practice for making the product, but maybe because of certain limitations, you can't execute on that exact process. You have to iterate, you have to use some other form to get that work order completed, so that product is done and good. But it doesn't meet the same requirements that the business is expecting you to do that. So how do you do that dynamically in the manufacturing sense so that IT and the business doesn't just break down?
It is a very good question. I'm not sure I have the answer, but Dave, what are your thoughts?
I think it is a really good question, Brian. I think you kind of laid out the problem for any sort of how do we go connect these machines? How do we go push it into higher level systems? How do we go compare machine one to machine two and facility one to facility three, sort of thing, right? We know that we've got to go collect this information in order to be able to get there. So I think the question is, how do we get there? Can you tell us a story about maybe how you're working with some of your clients, with some of your customers to define those? Before we can say, hey, we need this connected, we have to define the requirements. And I feel like you did a really good job describing how none of the requirements are defined before the machine is there. And it's why don't we have these 12 things that that we need? So tell us the story. How do you go walk through that process to help understand what we need to collect and then go through the process of that data collection?
Yeah. So to start with, there's tons of different ways on architecting this, and what we specialize on is providing data infrastructures and more specifically with a unified namespace architecture. Now, there's multiple ways of developing one and building one for your business as well. So there's tons of different offerings for a unified namespace or something around those lines to at least build one. So there's what's more important, I think, in the story of building it is understanding what devices do you even have. So like you have to inventory your business, understand what do you actually own, and from there, what are the data points that are available? First steps is just making the information available. However you want to do it, if you want to do it with an MQTT broker, if you want to do it with a NATS broker, with a Kafka broker, there's lots of different ways on making this available or doing it in a pub sub design. But what's important is to actually get the information up and out and putting it in a way that the business can understand. Either an individual that works at the business can understand, or the actual applications and processes will be able to understand for it. Your team is definitely a big aspect of that too, because they're going to be the ones who will be able to identify what's available as a source of information, but also what problems they're actually facing day in and day out. That's costing them a lot of time, and at the end, costing the business a lot of time and money. So it's definitely a big emphasis on the team aspect. The technology is getting there. I think it's getting more evolved, and I have my own opinions on how you should architect it. But I think that it's still very, every manufacturer is very different in their own way. And I think it would be immature of me to say that, no, this is how you do it. There's only one way for it. I think there's tons of different ways of applying it. But what's important is being able to connect, get the information, make sure that those who need the information have it available for them. If your operator needs to know what the quality is of the part that they just made, it's probably very relevant for them in that time and moment. We shouldn't be restricting them on those data points. Same goes for your procurement team on making sure that the inventory that they have is up to snuff. If you're relying on them to seek that information out themselves, you're going to be stuck with the older systems of Excel spreadsheets and stuff, where in this more data-driven architecture, we really want to emphasize on delivering the data to the consumers, whoever the consumers are, whether they're a person, an application, a device, a process, doesn't matter. But we deliver the data to them, how they need it, when they need it, and for however long. So those are some of the aspects on what we believe is pretty important for it.
There's a good question, Dave. I don't know if you saw it in the chat.
Yeah,
with
I'll
that.
go ahead. I was going to say, I think
Mhm.
Christopher is leading us down the direction of the conversation that we want. So thank you, Christopher. I will
Yeah.
say we've got 2 or 3 dozen folks listening to us live right now. The last I saw, if you guys have questions for Brian or Vlad or myself on the topic as a whole, please feel free to go ahead and drop them in the chat. Christopher is asking, how do you approach the initial machine discovery when scoping machine and asset connectivity? I'm assuming that you at least need to get on site and open control cabinets and view the PLC HMI to get the make and model along with the device com protocols, correct?
Yeah, so it's not only just the machines, what devices are on them, what protocols are available, what tags, what data points are available, but how can we get this information up and out? So what's their network infrastructure look like? Do they have managed switches? Are they able to do VLANs? Are they able to provide a remote connection for me as an integrator to be able to come in and add additions for it? So scoping out not just the plant or not just the machines themselves, what's available for them, but the plant's infrastructure, what's available for being able to develop, like put it in like a virtual machine. How are we able to inventory the MES system on what data points are available for there? So it's not just the devices, the machines and stuff, but it's also the applications that are running the business, because these are the things that are actually being transacted among the devices and the applications and stuff, and that's what's important. So inventorying on what devices are there, the protocols, the tags and the payloads for them, and same story when it comes to applications, understanding what's available, what's being used, what spreadsheets are being used, what's the
Mhm.
process being used, how do you get from a sales order to a work order, how do you get from a work order to a finished product, how do you get from a finished product to a product out the door, and it's identifying these workflows, how everything comes together in the physical form before you could do it in a digital way.
And if I can expand on that, Brian, just a little bit, I guess for me, it's always been the case that even the most advanced manufacturer does not have solid documentation of all of their assets, as you've mentioned a little bit earlier. So it will come down to opening actual cabinets and doing a walkthrough and writing down or taking photos of the panels to understand what's in there. But ideally, you do have some network maps that someone's maintaining in a spreadsheet. Ideally, there's some software that you can remote into and be able to see at least like an IO tree of the devices, right? But it's I don't think I've ever had a scenario where I could just not show up on site and get a full 100% clear
Oh yeah,
picture
no,
of the
no.
assets,
You,
right?
you
So
almost you almost have to pry in as much on like where are the Ethernet cables going, just about, because that's where the source of the
yeah.
information is going to be feeding in, and it's going to require a lot of just investigating on, okay, what's available, what do we have,
Yep.
what are you using, investigating with the operator, what do you do on a day-to-day basis, what are the tools, applications that you use to solve your problems, and that's where you're starting to connect the devices, but also starting to understand what are the underlying problems that a manufacturer is actually facing. Is it that
Yep.
they can't get access to inventory when the machine is starved? Is it they can't deliver on the product because the machine's been down and they can't get the systems integrator in to fix it? If these data points aren't being captured, you can't get to a phase of being able to automate it to prevent them from happening or being proactive about it.
Yeah. And I think, and again, to ask you maybe to expand on that side a little bit more, I think the frustrating part is sometimes the end users want to skip some of those steps, right? Because, like, let's be honest, it's not cheap to spend a lot of engineering hours talking to operators and engineering managers, supervisors to uncover some of these problems. But if you don't, then you end up having a very
You're going
expensive system without ROI, right? So,
Yep, you're going to miss it, and you're going to make it more difficult for your workers. this is all of this data and all of this work is really to make it easier for your operators and your employees to provide direct value. We don't want them to work on repetitive tasks that don't add value to the business. We need them to apply their skills in a way that provides the business direct value without hindering them. And that's where a lot of these automated systems start to come in, because engineers don't want to have to keep constantly updating spreadsheets to get the information that they're looking for, just for basic status on how's this machine doing, or where are we at on this work order, or we had 3 bad quality parts. Why are they bad? You won't be able to get these answers quickly, especially if you're not getting the data points for it. Where the difficulty then lies is actually connecting at that phase. And that's where a lot of that barrier is, and why it's been so hard for us to get past that is that connectivity step. So those are some of my thoughts on it. Yeah.
Dave?
Let me jump in and ask kind of one more specific piece on that before we talk about some of the other difficulties in going and collecting this data. Like specifically on the hardware software side, what are you seeing, Brian? Is it a lot of newer hardware? Is it a lot of older hardware? Are you seeing kind of lots of replications? What are you specifically seeing, and are some of the things being older making it more difficult to go find paths of connectivity, or are you saying, hey, we should really upgrade these? What is that conversation at kind of the very base controller level look like?
So we'll take the example of the US and the most prevalent brand being Rockwell. There is really no easy manner of getting data directly from a Rockwell PLC that doesn't involve either a software license or a less than ideal setup for getting data points from the PLC, and even if it's just status. So it's. Oh, repeat the question for me. I'm sorry.
Yeah, so I guess on the hardware software side, what are you seeing that the end users you're working with have? Are you seeing lots of replication? Are you seeing, yeah, kind of like talk to us about the physical hardware or the physical hardware and software that you're seeing, please.
Yeah, it's definitely PLCs. It's maybe more Modbus slave devices. It's still all of the very general, the same type of devices that we've been working with for years at this point. Everything being Ethernet, IP based, Rockwell based, and the current and the same practice of either buying a Kepware license or an ignition license to get the data up and out to higher level systems. But everything always trying to force you to a like some sort of central management towards it. So whether it's like a SCADA system like FactoryTalk, it's always about, okay, here are your devices. They all centralize here to the SCADA system, and this is the only way you can get that level data up and out. And that's been the going design for quite a while, and it's still the design that we see prevalent today, where you have a bunch of machines, maybe they got OPC on it, or maybe it's just like field bus Ethernet, and then it goes to an OPC device, and maybe it's ignition, maybe it's Kepware, maybe it's something else, but a lot of that is just centralized for just one edge gateway. And then you have to get that data up and out from that gateway. OPC is a little easier for getting that data up and out if there's already that infrastructure in place. But if you have direct machines themselves, especially if it's like a Rockwell one, they're not native for IoT protocols like MQTT, though that is now changing, but you just haven't seen much of that at all. We're just now on the precipice of machines like PLCs being able to natively communicate in a pub sub event-driven design, but the same story is still being sung about what manufacturers look like right now and how they're connected to their machines and how they're getting information up and out. It's still that central gateway, either SCADA or OPC, that connects directly to them. And that's the only way that you can get that information and do your transactions. Now, what we're starting to change now is breaking down that central control to where any device and application can now communicate whatever information they deem as necessary, as important. That is what you configure now, obviously. But we're seeing a lot easier of other applications being able to communicate with one another, which has been our biggest issue. If you try to use the old style of like a Purdue model of like physically trying to do Purdue model, you have level 0 sensors can only connect to level 1 PLCs, and then from PLCs all the way up to SCADA, and then from SCADA to MES and whatnot. And if you want data directly from PLC to MES, you have to go through SCADA. And if you want to get sensor data, well, it's got to go from sensor to PLC, then from PLC to SCADA, and then from SCADA to MES. What we're starting to see now is that you don't have to do that. You can get data directly from the sensor if you are using an internet-based protocol and a pub-sub model to make that happen. So now the hierarchy has flattened now, and our ability to communicate these data points has been a lot easier. Now, how do we translate that, the new design, into, or how do we translate the old way of doing things into this newer architecture is where the rubber kind of meets the road, and it becomes a very complex story of infrastructure. How do you connect this existing infrastructure that maybe in a green field you wouldn't dare do? Here's what you got to deal with. And how do you integrate that with the rest of the business? And how do you make this more future-proof? How do you make this where it is data-driven when originally it wasn't data-driven? It was more systems-driven.
Yeah. I really like that breakdown, right? Again, this goes back to my earlier comment, which I think people that haven't spent enough time on the plant floor understand, is that a lot of times the processes are not ideal, which usually means that, you have to kind of weigh different decisions like, hey, can we maybe pull data from this area because it's a little bit newer, but let's wait to upgrade this other area that has, PLCs from before you and I were born. And the reality is, like, you can do, right? I get this question also, right? Like, can we just leave it as is, and like, can we pull the data anyways? Like, the answer is like yes, but there's trade-offs. You're usually spending more money. You're usually spending a bit more on original engineering time, and you're going to create, in some instances, this temporary working solution that once you upgrade, you will either have to like modify or pull out. And it also brings a lot of, at the end of the day, why are we doing these assessments and collecting data? Is because we can modernize the equipment, make sure everything's working as expected, reduce bottlenecks.
Yeah,
But
squeeze as much juice out of that old equipment. I mean, it's still producing value. It's still producing good parts. What's difficult about it is that it's not integrated with your business. That's really the issue at hand. It's not that the machine is broken. It's that it's not a smart enough machine for a smart business. When the competitive advantage, like where the competition right now is, especially in automotive, you got to have things running at like 90% utilization, because like you got to squeeze as much out of that machine as possible. Why? Because A, it's expensive, and B, that's your money printer. That's how you make money, is printing it off. And where the value of the data coming from it is trying to utilize as much of that machine, print as much money off as possible, as efficiently for the business as possible. And that's where it's like, okay, well, hey, like, it would be great if it wasn't this dinosaur Slick 500 for us to integrate with. You know what? I'd agree with you the same. I wish it wasn't either, but this is what we got. Now, how do we integrate that with the rest of the business so that when we grow, either this can play with it, or eventually down the road, this can be replaced by a newer system, but still trying to squeeze as much out of it as possible.
Absolutely. Let me switch gears a little bit. I know we touched on this just a tad bit in the introduction, but
Mhm.
change management, I feel, is a huge discussion or I guess conversation topic in many of these projects, right? Because ultimately, as you've said, every plant is different, every environment is going to require, I want to say, a different approach. But people can either make or break some of these engagements. So I'm curious maybe to hear some of your thoughts on, again, maybe something even to start off as fundamental as what kind of resources would you need, coming into an end user on the end user side to pull something off like this successfully, right? And obviously you can define what success truly means, but
Yeah.
you need to have those conversations and understanding of the business.
Yeah. So for individuals that want to solve their problems with data, I would say focus on what you have domain over. If you're an operator and you have domain over a CNC, and you want to know more about your CNC because it affects you. Now, you may have grainer visions of maybe we could apply this to the rest of the plan. Maybe we could apply this to the rest of the business. Those are good Granger ideas, and that's what we need more of. We need more people like that. But you need to start with what is it that you have domain over and what you can control. Start with what holds you back from providing value. So downtime. Is it you can't get enough parts when you're operated like you're starved of parts? Is that part of your bottleneck? Is it you have other operators that are not doing their job down the line that's causing a bottleneck on your end uh,
Mhm.
or I'm rattling off examples, obviously, at this
Mhm.
point, but it's very important to focus on what you can make a change in your daily life. The advantage of that is that you can go to your higher ups and show results. There's nothing that's going to beat the theories and the consultants than literal results. Because if you've shown that, we had a lot of, I was being starved of a lot of parts. You want to know what I did? I got in contact with our IT guy that was in charge of the warehouse. Don't ask me how, but I'm able to get that information. And because I have that information and I can query it the way that I need to, I can get my problem solved. Now, maybe it's just for yourself. You can put that on a resume, or maybe you could bring that back home and automate a garden. We'll say that. You could still use that result to bring it up to more management on, hey, this is what we were able to do for the one production line. What if we did this for all of the others? Or what if we did it for the next step up? Because at that point, you have results and you have traction as compared to theories and a consultant saying otherwise.
There's a few good comments and questions based on that. Let me bring them in. So one is from Yusuf. He's saying that the only technological advancement at the factory where I work is the transition from Profibus to Profinet, because a major transformation requires a lot of courage. Right. And I guess maybe to throw this or expand on this a little bit on Brian, like, do you see a lot of this change driven by, operators, managers, supervisors, directors, VP, C-suite? Like, what does that usually look like for you?
So those who are driving it are more of the engineers, I would say, more of the IT, the people that are responsible for providing these solutions. I think that these are the ones that are being driven by it because it's their responsibility. And I think they're being employed to make it happen. However, it is that they're supposed to make it happen. Um, and I think that the vast majority of the general automation brands have not been catering towards that, or if they have, it's been always a big ticket item that wasn't really designed for the engineer. It was meant for to please management. So I think there's just been a very big disconnect over the years on what engineers need to solve their problems and because of what's been going on recently with with all the new technologies that's been coming out, the game's just been changing, and the competition's only been getting harder. And when you're taking those into account, the engineers are being tasked with more and more data IT type of jobs where, IT was used to be responsible for maintaining the firmware on a PLC, or there's a PC on the edge, like maybe it's like an old Dell, like a SPC that's just sitting on the edge connected to the PLC, so that it could get some data from it and put it in an Excel spreadsheet. Where it's like, you have a lot of applications that are like that, where the engineer is being tasked with IT type of jobs, and there's certainly just not enough IT skills in the manufacturing domain to go around. So the demand has gone up tremendously, and it's only going to keep going, especially now as with AI being on the forefront, and where a lot of the information that is available kind of originates in the manufacturing domain, yet we don't have access to any of it. Now, we've alluded to why that is because of how heterogeneous it is, but the engineers are still tasked with getting that information and completing those business processes that they're tasked to do in those workflows.
Absolutely. The one comment, Brian, I will add, right, and you've mentioned this a little bit earlier, is that, it's very important to get the operators involved. And I would say that, to the comment that Yusuf has made, sometimes the operators should be reaching out to the engineering teams, right? Because obviously we also have our own biases, so to speak, and
Mhm.
we're trying to solve problems that we believe are the main problems. So if you come
Mhm.
sometimes to us, obviously we're busy on other tasks and projects, but that doesn't mean that the problem you're bringing up is not important, right? So if you describe it in a way that you understand and present it to the engineering team, I don't see why they wouldn't be, at the very least, be willing to listen. And two, if there is a project where they can incorporate some of that, maybe provide you with at least some data to understand the system better, you know what I mean, and make it happen. So I think it's important to say that, yes, the engineers implement a lot of these solutions, but that doesn't mean that the operators should be shy about maybe bringing this up with the engineering teams and maybe point them in the right direction. Because ultimately, like, I agree with you, the operators spend a lot more time with the machines, and they understand.
They're the ones
the
that actually
problem.
provide the direct value to the business, and that's
Yes,
you will get a better manufacturer if your engineering team serves your operators more effectively, as
correct.
compared
Yes.
to the opposite. And then to go on to more of your point, the operator creates the problem, the engineer solves it, the IT guy maintains it.
Yeah, I like that. I like that. There's a few more comments. Let me bring this one in, David, and pass it on to you. This is a very common question in our space, I guess, in general. So, Amina is saying, nowadays we see a lot of sensors and actuators that can directly communicate to SCADA through, as an example, Modbus TCP. Does it make sense to collect this data through PLC, or is it more efficient to connect sensors and actuators that are directly from themselves and let's say the SCADA system? So, what are your thoughts? I guess this is where, like, the UNS ultimately comes in.
Depends on, like, okay, is this like is it a unit? Is this like a equipment unit that these Modbus devices are connected to? So, like, an example is a wrapper, something that just wraps boxes like pallets. Okay, that's going to have some actuators on it. That's going to have some sensors, and there's going to be a controller that pulls that data, the data from the sensors, and then tells the actuator what to do. Now, you could connect that stuff directly to SCADA, but should you? In that case, I don't think that's the appropriate one. And the reason being is that that wrapper is what we consider a unit or a piece of equipment. You really want to try to have that be more of a more of a unit, where it's just one body that you want to represent, but you can still get that information up and out. When it comes to actuation, you always want to have that be behind some sort of control layer, whether it's a PLC or whether it's a SCADA system. It very much so depends on can you unplug this unit from the wall and move it somewhere else? Is this more of a whole solution, or is this just a random device that just so happens to get power and network from this machine, but has nothing to do with the actual process that it solves? And that's where it's like, okay, for the existing network infrastructure and the way that's being interpreted by the business, keep those together, because you're going to always utilize it that way. It doesn't mean that you can't get the data from it directly through the PLC. It may even be better through the PLC rather than pulling directly to the slave device, because that's going to introduce more of a spaghetti network, while in what we're trying to do is more of a pub sub, where you just want to have one central location where all of those are communicating to. And if you have a bunch of slave devices under one PLC, it would be much better to have those slave devices communicate to the PLC, which controls them, tells them exactly what to do, has full dominion over, than it would be just to have the PLC tell them what to do while these other slave devices are publishing up and out. It's more like extra steps, extra connections that don't need to be there.
Mm-hmm. Dave, what are your thoughts?
I think that question, we can tell how divisive that potentially can be just based upon the number of comments we've gotten. I'm going to go read a couple more. So Jacob commenting back to Amen, talking about how he thinks it's logical compute for controls is arguably moving up the stack into the mainframe, and server stacks as soft PLCs are starting to get more powerful, and direct connection sensors is novel and an interesting feature. And I agree. I don't think you can have any sort of conversation around this and not get 7 different answers, not get the everything should run through the PLCs, or let's just go put a sensor layer on top of my machine or line layer, or let's go put sensors, or let's go leverage soft or virtual PLCs on the mainframe server stack side. And I don't know. I think it's interesting.
I can never be wrong because of all the different ways you could do it.
I was going to say, I would say for long-time listeners, you guys know Vlad and I have had, several dozen debates as to the directions you can go. And at the end of the day, for me, it's very much based upon client needs, right? Because if I can go buy, call it a $100 smart sensor and solve the problem, or I can do a $300,000 project in which I take this $100 smart sensor, replace all of the infrastructure, pull it into a PLC, network it all the way back into the server racks that we're hosting our own potential ERP, right? Like those are 2 ways of potentially solving the same problem. And it's a very different conversation than, to go finish the points, when Vlad and I always talk about this, in Vlad's mind, he is always the person who is the controls guy or the maintenance guy or the person in charge of it. And he can just open his logics. He can just go add a sensor in there, and he can just go directly send that sensor from the PLC into whichever SCADA or ERP or other solution we're using. So I think it's really dependent upon the infrastructure that the organization has and the people and what the competencies are.
Yeah. Who's going to maintain this? That's always a consideration that you always got to have with this. Is like, you could connect these sensors, these devices up and out to it, but who's going to be maintaining this sort of stuff? Obviously, if it's just through the PLC, you're going to have the PLC guy do it. But if you do things in a very custom way that isn't where somebody isn't going to be taking responsibility for it, guess who's going to be taking responsibility for it? You're the one that came up with the idea. If it's not, well then somebody, eventually it will be when it breaks down or it becomes a problem.
Yeah,
Absolutely.
it's gonna be a never-ending debate, right? Like for me, again,
Mhm.
like I agree, it's business driven, right? But you have to consider, I think, all angles, right? There's also the question of technical debt. So maybe you introduce something that's cheaper today, but ultimately, in 5, 10 years, you have
Mhm.
again many examples of proprietary platforms in the cloud where you're piping that data that have shut down for a number of reasons, and you're left with a paperweight on the on the plant floor that's probably still flickering the LED light, but not much you can do with said information, right? So I think it's for sure business driven, but it's not. I would say it's not just cost. It's really like what is right for the business and how do you do it in a way that makes sense for
Mhm,
them. Dave, you want to
mhm,
bring up? There's a few other questions I think and follow ups on this whole like
Sure.
red.
We do. So we actually had a comment from Christopher that I don't
uh,
see pulling over on LinkedIn, but I feel like we answered it. And that's why I'm going to bring it up. But he's saying with the different hardware required to collect data and ways to connect to a UNS, how do you narrow it down to what hardware software to use, customer driven, integrator, recommendation driven, etc. And I think it's very much the comments that we just made is it really depends upon the competency of the people in house, and sometimes the in-house people are your service contracts with your integrators, which would scare me, um, for all but maybe the very largest integrators that have multiple people who know your systems very well. But I feel like
yeah.
that was a really good time to go bring that up. Yeah, I feel like that's a really good time to bring that up. And then um, Mark has a comment who makes us kind of really rethink all of these questions, as he often does. And thank you for that, Mark. He's saying we as OT professionals are too accepting of the narrative that we need to figure out how to pull data from legacy machinery, and we come up with incredibly innovative solutions where we should say we have 60% of our PLCs over 30 years. Uh, or no, and we come up with incredibly incentive solutions. He's saying we should say we have 60% of our PLCs that are over 30 years old, and we need to migrate these to more modern PLCs so that we can succeed for the next 50 years. Uh, I agree. I think it's harder said than done, at least in the solutions that I've
Mhm.
worked. And I will say, while we're bringing up PLCs, Brian was talking about some slicks, some slick 500s, 505s. Brian, I wish my old PLCs were slick 505s, right? Like, I wish we could be as modern as slick 505s and calling them old.
Yeah. So here are my thoughts on that too. We're never going to get away from legacy. Never. Do you know why? Because they're
Be-
hand downs. Why would you turn down a money printer?
because of accounting, 20 years.
Yeah, it may be. I mean, shit. We got like presses from 1920 that are still operating 24/7 today. There ain't nothing broke about them. What's broke is your ability to use them and use them in your business, and that's why we're ripping and replacing a lot of that sort of stuff. So we will see like more of the more advanced ones. Of course, they're going to upgrade. They're going to have the shiniest stuff, but we're never going to truly get rid of a lot of this equipment. It's going to be sold off. It's going to be sold to the different companies that are going to use them for their business at a more discount rate. Now, where this kind of goes is how well can we effectively use the legacy equipment? It's not going away. It may go into somebody else's hands, but how are they going to leverage it further? Because this isn't just going to be one machine. This isn't going to be like a 5 year problem of ours. This isn't going to be a 5 year problem of ours. This is going to be a lifetime thing that we're going to be stuck with because they
Mhm.
still provide direct value. And even if they stop, we're going to sell them to somebody else who's going to find direct value to that. And we're just going to always have these legacy equipment, these legacy devices that we're still going to have to connect to no matter what, because there's going to be one business unit that needs to have that information.
Absolutely.
I I certainly agree with that. We've got a bunch of comments, so thank you everyone for the comments. We've got Dustin in here. Dustin's made a bunch of great comments towards our listeners. But Dustin, towards Mark's comment, says he currently has a PLC-5 to a KF2 serial to Ethernet gateway set up in his office right now. And if that's just not like a series of hand-me-downs that Brian was saying, I mean, I wouldn't be surprised if that PLC-5 came out of a client site at some point, or a dumpster behind a client site at some point. But I 100% agree with that. Jacobs also has been in the comments, including his Slick 505 type of vibes. But Jacob is saying, and this might be the most divisive question of all. Man, I feel like this should be one of your normal questions if you really want to put some pressure on one of our guests. But Jacob's saying, do you think that controls will find themselves consolidating into a communications protocol like TCP/ICP or TCP/IP in telecom? Brian, I'll let you go, and then maybe we'll do a round robin for answers.
So, I mean, protocols I like. I love EtherCAT. Awesome. EtherCAT's awesome. If we could have more EtherCAT, more to the world over. It's the reality of the world is that it's a story of where we're going to always have Profinet, we're always going to have Profibus, we're always going to have Ethernet IP, we're always going to have EtherCAT, whether you like it or not, and how you integrate that with your business is really going to be your choice. And that comes down to the business's directives. Do they want to have everything be TCP/IP? What's the value of that? What's the value of all what's the value of one specific protocol to rule them all? Until we get the vast majority of the devices, the infrastructure, the businesses that utilize this equipment to agree that these are the only things that we care about. We don't care about these other type of protocols. That gets out, that goes away. Until that tends to happen, those protocols are definitely always going to stay there. And the feature sets are definitely always going to stay there. As for TCP/IP compared to UDP, TCP. I mean, that's another low level end that, like, it's. I think it's like
Who do you even send over UDP? Do you have undeterministic?
Yeah, I know. There's values of all of these things. There's tons of values of all of these different things. And we are always tending to consolidate on technologies, consolidating on practices in general so that we don't have to repeat ourselves. But there's always value in doing things a different way, either a different way that we've done before or a different way that somebody else has done in the past. There's always some sort of value there. The story is how you can leverage it to its fullest extent. So do I see that the controls world will consolidate on a communication protocol that also is in telecom? Possibly, but that's until telecom has a direct need to consolidate on controls, on the control TCP communication protocol. Until that day happens, don't really see any sort of future with that. And I think in the next probably 50 years, we're really not going to see that.
I was just going to make the comment. Jacob clarified, saying that TCP/IP was his comment re telecom standardization. He thinks MQTT would be his proposition for the standardized protocol. I don't know if it changes. I feel like Brian's answer is a really good answer of something will have to happen to go force the change. Dylan is suggesting we need to build something on top of CAN bus, which is in fact what it's what Dylan has been up to. He's been posting on LinkedIn and building on top of CAN bus.
Yeah.
Look. Go ahead, Brian.
I mean, I love MQTT and what it provides as a feature set, but it doesn't serve all of the things that we're looking for. It like MQTT for a secure connection on a very unreliable network. oh my God, amazing. You can't hack into it. It's very hard. You close off all the ports. The best way for you to hack that device isn't hacking the device, it's hacking the broker that device feeds data to. So like MQTT has its really strong skill sets, but in a lot of domains, it still doesn't solve a lot of the critical features that we needed to solve, like a persisting state. And also when it comes to some of the features that do come with MQTT, like that high resilience in a network, that's all well and good. But how many manufacturing environments don't have like a direct Ethernet connection with a redundancy involved with it too? How much is that how much of that redundancy is really valuable in MQTT? It's not as much, but there are definitely pieces and parcels of it that are very valuable, where the overhead of the payloads themselves are very small. For the small IoT devices that are very constrained on resources, or on those very small processes where you just want to send an update, where rather than like sending a REST API call just to say something happened, it would be easier just to send a MQTT message. It's a much smaller footprint for a small data point, essentially. That's where you'll find more MQTT and more of the utilization of of that protocol. But we're definitely going to be finding a mix of protocols being used for solving the various problems that we have.
I would say, in my comment on this topic is I think we're consolidating and more protocols are being removed, so to speak, especially the very proprietary ones.
Oh
But it's
yeah.
going to take a lot of time, right? Like it's very expensive. It's, I do a lot of conversions on the Rockwell side and it's getting rid of device net, it's getting rid of control net. And a lot of times the moment you start touching even data highway plus, like it's impossible to just, hey, like let's upgrade these 3 nodes that are on an island, right? You start to upgrade the entire chain. You have issues with the firmware of your older drives, older IO modules. So the project from being just the PLCs has now become $5 million to upgrade all of these 10 cabinets that are connected over data highway plus and some device net loops and whatever else has been deployed. So I think it's a very complicated question,
I
but
think if
slowly.
anything, we'll get to the commercialization of automation. I think that's what we're heading towards, and that's where it's becoming, where it's not just the big boys get to have the automation, get to have fun with it. It's going to be the commercialization, almost down to the individual that wants to automate something. And I think that's where we're starting to see this battle now of the protocols, where you got the proprietary ones, you got the open source ones, you have the ones with specific feature sets, the other ones with others, more general feature sets. And how do we want to use them? And this is where that battle is being played out now.
Yeah, and I would say that if you have a protocol standard, I see, again, most devices nowadays, and you've touched on this a little bit, Brian, as well, offer a lot of options, right? Or at least some of the most popular options. So I don't see any, let's say, necessity to, if you've standardized on MQTT for some random reason, you're like, well, let's deploy this device with only OPC UA or DA for that matter, which is also to some extent obsolete. But ultimately, I think you should be thinking about standardization on the protocol side, and hopefully you, and when I say you, it's in general as a controls engineer,
Provide
like eliminate
a
things.
minimum, just a minimum requirement. I wouldn't even say standardize on one. I would say provide a minimum requirement for it. So this is where, okay, hey, at a minimum, we needed to be able to communicate MQTT. The reason why is because that's how we just get a data point. That's so that so that the light bulb that I got in my office will be able to communicate with it, or the other little IoT device that I have is being able to communicate with the inventory system that I have. That's where you're just providing minimum requirements for it to interact with your system. Now, if that minimum requirement is that it can either be Ethernet, IP, EtherCAT, Profinet, MQTT, OPC UA, well then, hey man, world's your ocean. You can really do anything that you want with those requirements. But if your minimum requirement is that it can only talk MQTT, well, you got a smaller pool to work with. And so that's where the business decision, the business strategy of how do you architect it? How do you want this all to go in? What do you have? What would you like for it to do and have? It's a really dynamic place, and it's really interesting. Some of the solutions that are coming out, and it keeps evolving. It just keeps getting better.
Brian, we're getting like dozens of questions, and the chat has been, I guess, very active on this specific topic as we started to discuss it. But let me ask you, because I did want to bring this up, and I know we're a little bit over time as well. But you do a lot of work with the UMH architecture specifically, right? So I wanted maybe to get a clearer picture, and I know we had that conversation at Automate, but for someone who's trying to understand what a deployment on, what you've been describing looks like, could you paint us a picture again? Like, is it a server? Is it the software? Like, what does it look like? What does it look like to get to maybe a POC, a proof of concept, to get some of that data and start visualizing it from the controllers?
Right. So we've been doing a lot of work with UMH, and to be honest, we've got them to change a lot of things. And so what we presented at the Prove It conference has changed drastically. Like the product itself has changed. So there was the original UMH where it was a Kubernetes Helm chart, which is pretty much a configuration file for running multiple applications in high availability. And so they still have that still operates and works. But what they've done is that they've gone back to the drawing board, and they've taken all of the good things that work with that, all of the bad things, and all of the requirements that they've learned from working either with us or from their customers. And they distilled it down to now it's just a container, or if people aren't familiar with it, it's a single application that runs on a device. So it's now what it is it's still the core aspects of UMH now more than ever. So it's utilizing a Red Panda Kafka broker, which is the central broker for distributing all of the events that are occurring, and Benthos UMH config. So what Benthos UMH is a streaming processing pipeline tool. It's dedicated for doing ETL pipelines where you're doing data ops, where you get a payload that comes in. It's agnostic about whatever payload. It's fairly agnostic on whatever protocol, and you can transform that data however you need, but providing it in a single config file, which makes it much easier to maintain, especially from an IT perspective, if you're trying to do more of a version controlling with it.
Mm-hmm.
And the benefit, the benefit with it is that, you can even spin this up version controlled in seconds. So like one command could start it up, and you could have the infrastructure connecting already to devices in seconds with minimum resources. You could run it on 2-core CPU and I think 4 gigs of RAM.
Oh, don't give people ideas to put more Raspberry Pis on the.
I'm having an issue. So I'm very involved in the 4.0 community Discord, but you'll notice that there is a staunch lack of me talking about UMH. And it's like I don't want to break the Discord community servers rules on like sales and all that sort of stuff. And I also didn't want to overinflate the Discord on UMH, but it really is something else. I'll tell you that, because we've been working with them directly on this exact problem, on connecting to all the disparate devices that you have. How do you connect to them? How do you model them? How do you do this at scale? And how do you do this where IT can be involved too? Because we're realizing more than ever, this isn't just a story about OT. This is a story about the entire industry, everything that's going on the manufacturing plant floor, everything that's going on the carpeted side, and everything that's going on in the IT, in the closets, in the rack. So more things onto UMH. I mean, it's still that pub sub technology, but rather instead of a MQTT broker, it's a Kafka broker. If you look at both of them, they're actually very similar in the way that they're structured. It's a hierarchy structure. Instead of in MQTT, you have all the various topics, and then there are direct payloads. There's a key in payloads, but there's still topics and stuff. So it's very, very similar. I'm over explaining it, but essentially they look very similar to it. But the difference to it is that Kafka persists the events and distributes those events to other brokers or to the other systems, and does so utilizing the full bandwidth of the Ethernet cable, as compared to MQTT, where it's meant for high amounts of connections, but only small payloads, being able to communicate only current state. Sure, there's retain, but there's only so much you can do with it. Sure, you could retain data events in the payloads, but now you need something on the other side to decrypt what that payload means, which it kind of negates the point of it. So the big difference with it is that it's Kafka rather than MQTT, but it doesn't mean you can't bridge the two together. Yep. And this is where it's like in the original design that we had, that we showcased with Prove It, it was a whole config file with Kafka, with MQTT, with Postgres as a database, as a historian with Timescale DB, now Tiger Data, Grafana, Node-RED. It had a whole bunch of other things. They've distilled it down to what's important now, and that's the actual unified namespace and the pipelines that connect everything together. So that's what they've focused on, the core. There's going to be more to come with it too. There probably is going to be a Kubernetes type service, but there's a lot of reasons why for it. Some of it came from what we did with Prove It, and others, of course, on their own experience with their customers. So, yep. So a little more background on it. They got away from, I wouldn't say they got away from it, but they realized that a lot of manufacturers are not ready for Kubernetes, like at all. And to be honest,
who would have thought? Who would have thought?
Oh my God! So I've done Kubernetes, and it is just something else, man. It is something else. You need a whole team dedicated just for Kubernetes, and in manufacturing, we just are not there. The Kubernetes itself is just not there for one individual to manage. But individuals can manage single containers. So what UMH has done instead is, rather than focusing on providing everything that a manufacturer may need for MES, for getting connected, for all this sort of stuff, they decided to focus on the core aspect, which is the unified namespace, the actual backbone where the data gets fed in and fed out. So that was really what they wanted to go back to, and that's how they were able to condense it down into one container. How they did it is really cool. I recommend try to poke and prod as much into the Discord or into the source code as possible. It's free and open source too. It's a license to the Apache 2.0. You can do whatever you want with it. But it's a phenomenal container, to say the least. It's only getting better. So yeah. Is there anything else you want on it?
I think that is fantastic. Thank you so much, Brian. We've got a bunch of questions and other comments. I will say we've got a bunch of questions and other comments. Guys, we will do our very best to go get to those after the show. One point that Christopher asked is if it's being recorded. You guys are watching live on LinkedIn. It is up on the Manufacturing Hub YouTube channel and will always be there. If you guys are listening in podcast form, you guys can, I assume, also go watch it live or record it of live. Having said that, Brian, thank you so much. We do want to ask you the same questions we ask all of our listeners. First is, we want you to go predict the future. What do you think that the future of data collection in manufacturing looks like in the next 3 to 5 years?
It looks like, it's going to be completely different from what you expect now. The amount of central hubs that you kind of have for connecting things, like we mentioned, where you have an OPC server, that's a central thing. Then you have an SCADA thing, that's a central thing. Then you have MES, that's its own central thing. I think what we're going to see is a lot of those centralized things just being flattened and having more of a flat architecture. Things are going to be more connected with each other, and the abilities to communicate with each other is going to accelerate because of the flattening that we're going to be seeing with this. Yeah, I mean, I got other views of the future, but for that one, we'll just stick on that.
I like that. Thank you. Thank you very much for that, Brian. Next question we'd like to ask is for some career advice. If someone else is early in their career and maybe looking to start their own company, is maybe looking to go down a similar path of learning some of the topics that we're talking about today, what's the best piece of career advice you can give them, or what's the best piece of career advice maybe you had 5 or 6 years ago?
So the outlook that I had personally when I was starting the business is that this could either go one of two ways. This will make me a lot of money. This will either make me go bankrupt, but at least it'll look really good on a resume. So the downside to it is that's kind of what my mindset was, at least going into it, is that at least it is either going to bankrupt me, but it's going to look good on a resume, or business will become successful. As far as resources, getting started with this sort of stuff, or this is the sort of stuff that you want to do, it is a better time than ever to have access to the same technology that enterprises use day in and day out. As an example, you could download and run Odoo, which is an ERP. They call it CMMS software, but really you could use it as an ERP software. That could be a playground for you to use as an example of a manufacturer. You're starting to get virtualized PLCs where you can have an example PLC that you want to learn and program on, and that you could even run on your own PC. So now is more time than ever, not just to look up a video or research, but to actually try and to deploy and to experiment and to try things, get the actual experience. You don't necessarily need to be educated on it. You need to find the information where you're looking for, but try to achieve something with it. That'd be some of my advice.
Awesome. No, thank you so much for that. So longtime listeners will know typically we ask for a book or a content recommendation, but Brian said that he spends most of his time reading technical manuals. So Brian, what's the most interesting technical manual? And I feel like that's a really low bar. But what's the most interesting technical manual that you would like to recommend for us today?
So I've been reading more on Mesa's BatchML documentation. And the reason for it is we're looking more at seeing what we can do on providing more transactional schemas in a unified namespace. And the kind of idea and thought with it, and this kind of goes to conversations I've had with David Schultz and with Dylan, with Dylan on how can we improve the unified namespace. And what we're starting to kind of experiment with, or an idea on, is rather than having a bunch of bespoke schema, payloads, data models inside of a unified namespace, it would be easier for consumers if they understood one transactional schema. So an example for that, we'll say for recipes, it would be easier to consume a BatchML schema, a payload, than it would be to get some bespoke payload that came directly from one of the machines. It represents the business exactly And if there's something on the other end to consume that information directly, more power to you. But what we're starting to find is that on the consumers that are trying to consume this information, there's tons of different ways for them to consume the information. And then there may be missing data points with it. Or it's difficult for you to understand the payload and to create a pipeline to get that information out of the unified namespace. So what we're starting to see, what we're looking into more is providing standard transactional schemas like BatchML being the medium for devices to publish and for consumers to consume. The advantage of it is that the equipment may not have a really good example of how the business wants to interpret what a recipe batch is, but what would be a good starting point is BatchML. It already has a lot of the data points that you could need for it. There's already standard transactions of understanding it, and the information is really well and prevalent. And there's already systems that natively ingest BatchML payloads themselves. So if you're ever having to utilize something that already exists, if you could put it into a standard transaction, that's kind of what we're going for. So anyways, that's what I've been reading into. Something I recommend, especially for manufacturers that are kind of starting out with this. We see BatchML being a really good stepping point.
Is it an open source resource that anyone can access, or is there a fee to get the documentation?
There is a fee.
Okay.
Yeah, I think I may be wrong on that, but I think Mesa has to.
We will go confirm this after the show and go drop it in the notes. Vlad asked a question that no one was prepared for. It's a good question, but Vlad has asked a question that no one was prepared for. But no, thank you so much for that information from Mesa and on the BatchML side. It's questions that we've kind of waded into, but it's very interesting to see those models or those thought processes and the different, in theory, competing models and thought processes. But that's a completely different, 3-hour conversation on what is the similarities and differences between all of them and which one of those, and will there be a model that wins in the end. Having said that, Brian, this has been fantastic. Last question for you is, how can our listeners help? Who should reach out to you? Who do you want to connect to on LinkedIn? Are you looking for new customers? Kind of any and everything our listeners can do to continue the conversation with you.
So all of the above of what you said. If you want to get a hold of us, you can contact me at bribe@mockcontrols.com. You can contact us either directly from our website, LinkedIn, or Discord. We got a lot of options for you. And if you have any questions, if you want to, if you need any help with these types of problems, we're always open for helping you.
Awesome, Brian. Thank you so much. And everyone, thank you for hanging out with us. Again, if you're listening, Vlad, we've got a dozen listeners on your X profile right now. So I don't know if you've done some good things or some bad things, but this is the most former Twitter listeners that I've ever been able to highlight. So everyone, thank you for coming and hanging out. Make sure you're following Manufacturing Hub and Brian and Vlad and myself. If you've caught some of this but want to go back, the best place to do it is on our LinkedIn channel, Manufacturing Hub, our Manufacturing Hub Network. While you're there, do the like and subscribe thing for us. If you're listening on podcast format, you guys are great. Thank you so much. We should hopefully have updated show notes with all of the links. And by we, I mean almost exclusively Vlad is extremely good and going and collecting all of those so that you guys know what the heck we're talking about. Until next week, we'll see everyone soon. Thank you. Bye-bye.